3.2, description of programming project number 1. Yeah. So let me describe this project first. Yeah. Later, I will give you a document. In the document, I will write a detailed description. Here, I just give you the, description, what I like you to do here, yeah, in this project. Yeah. All right, yeah. We do this, evaluate polynomial, okay, yeah. So we do this, evaluate the polynomials efficiently all right, the title of the project, okay? And we just learned that material, so we know how to evaluate polynomial efficiently. So we know the efficient way is Horner's rule. Yeah, so implement Horner's rule, but we need to do comparison. Otherwise, you may not know how much better it is. Okay, yeah. So here in this project, we need to implement polynomial evaluation in 2 different ways. Method 1 and method 2. Yeah. Method 1 is that ordinary method. I just call it ordinary method, because there is no specific name for it. Okay, yeah. And method 2, Horner's rule. And we can do comparison. Yeah. Because these 2 methods, all right, they should return the same result. So we can check if our Horner's rule implementation is correct or not. Yeah, because you may implement Horner's rule in the wrong way. How do you know it's correct or not? We use ordinary method to do comparisons. If both evaluations give us the same result, then we have the confidence. No, we have the confidence. No. 2 completely different methods return the same result. Think about how can 2 different wrong methods have the same wrong answer? That chance is very little, right? Yeah, that's possible. That's possible, but that probability is extremely low. Okay? 2 wrong methods, they return the same wrong answer. Yeah. That's possible, but that chance is extremely small. Yeah. So when they return the same number, then we are very confident this result should be correct. Okay, so based on this real world experience, this should be our real world experience, right? Yeah. So we can make sure our implementation is correct. Okay. Yeah. After that, we need to compare response time. Yeah. All right. Yeah. So first, we need to return same result. Second, we need to clock the response time. For each method. Which one is faster, which one is slow? We use the response time numbers. Yeah. The response time, yeah. So we like to use the milliseconds. Yeah. So usually milliseconds. So we expect, dozens of milliseconds. Yeah. Based on your data, how large is your data? So milliseconds, dozens of milliseconds. Yeah. Okay. Yeah. All right. And the Horner's rule should be much faster than the ordinary method. Yeah. So that's our expectation. Yeah. All right. So then we will look at the data. Okay. Yeah. What kind of data? Yeah. So the data. For this project, so I want to consider integer data. Integer data. Okay. Yeah. Not floating point numbers. Yeah. I want to use integer data. Yeah. Yeah. Because for the floating point numbers, numbers 4. So we have two places we need to use data. One is the coefficients. One place is the variable. These two places. If we use floating point numbers in these two places, we may get some truncation errors. So what's that? Truncation. Remember, in a computer, when you use floating point numbers, when you calculate it, let's say floating point number x, okay? So you have a floating point number x. But now you need to calculate x to the kth power. Think about that. You do multiplication, x to the kth power. Then, do you know your computer can keep all the digits without truncation? It's impossible, right? Yeah. When you raise your x value to the kth power, it's very likely certain number of digits will be truncated. So that's the truncation error, okay? When you have truncation error, these two methods, method 1, method 2, may not return exactly the same number. They will have the last few digits different due to the truncation errors, okay? Yeah, slightly different due to the truncation errors, all right? Yeah. Now, for this project, I like to switch to integer data. Then we have no truncation, right? When you do integer calculation, integer multiplication, you do not have any truncation, right? Yeah. Our computer, we keep all the digits, no truncation. Then when we compare the results of these two methods, they should be exactly the same. All the digits must be exactly the same. right? Yeah. So for that reason, I picked the integer data to avoid some possible truncation errors. Okay, yeah, all right. But the question, after we eliminate, after we avoid the truncation errors, but we may have another problem, another important technical problem. Yeah. So what's that problem? Problem is overflow problem. Okay, this overflow problem is pretty big, pretty important. We cannot ignore. So what's the overflow problem? Because when you use integer, so let's consider the largest integer data type. Here, let me use Java, okay? Java, okay? Yeah. So it's called a long integer, long integer. Yeah, just keyword long, but it's long integer. And this data type use 8 bytes for one integer, to represent one integer. Yeah. All right. 8 bytes for one integer. All right. Yeah. But 8 bytes, there is a limit, right? How big is integer you can represent? Yeah. 8 bytes, 64 bits. 8 bytes equals 64 bits. And the first bit is the sign bit. The first bit is used to represent, plus minus sign. So we call it a sign bit. So it cannot be used to represent number, the value part, sign bit. That means the largest integer you can represent is 2 to the 63rd minus 1. Okay? Yeah. This is the largest long integer. Okay? But when we do our calculation in a polynomial, we can easily get our polynomial value greater than this largest long integer, right? Yep. We can easily get an integer greater than this largest long integer. Then we get overflow. If we get overflow, the value would be wrong. When you get overflow, okay, the computer overflow occurs because your number is greater than the limit. Yeah. So overflow occurs, then the last 64 bits of the integer would remain. Yeah. The bits higher than the last 64 bits would be truncated. Okay? Yeah. So the higher bits would be truncated. Okay? Yeah. When this overflow problem occurs, then you get a wrong answer. Your polynomial value would be wrong. Okay? Yeah, would be wrong. So the question, how to avoid it? We want to avoid this overflow problem. Okay? Yeah. So the solution is here, still in Java, in Java, yeah. We can use a special Java class, a special Java class. A class called big integer. Okay, this big integer. Yeah, let me write. No. Yeah, big integer. Okay, the name of the class. So with this special Java class, then no overflow. Overflow. Flow. Okay, you don't need to worry about the overflow. Okay. Yeah. Yeah. That's in Java. All right. Yeah. In Python, some students may use Python. In Python, you don't worry about this overflow. Yeah, because its integer implementation already takes care of the overflow problem. Okay. Yeah. I think use the similar idea of this big integer one. Okay. Similar. So in Python, yes, some students, if you use Python programming language, so you just use the integer directly. Okay, you don't need to worry about the overflow. All right. Yeah. But in C or C++, now some students may use the C++. Okay. C++. Yeah. Okay. Yeah. So I do not know what's the best way. Yeah. If you use C or C++, you just, try your best. Okay. Try your best. So when you select the data, you try to control, not overflow, right? Yeah. Try to, do the experiments, not overflow. Yeah. Just try your best. Okay. Yeah. Or if you can find the easiest solution for the overflow, that also would be good. Yeah. Yeah. But I cannot give you a suggestion here. All right. C++. Yeah. All right. So, yeah. But in Java, how to use the big integer, I may provide you an example. This integer class, it's pretty simple to use. Yeah. Yeah. I may give you an example. In my example, I will give you how to generate random integer with given number of digits. Okay. For example, I want to generate 10-digit integer. Yeah, so then I have a method to give you, yeah, it's simple. Yeah, it's simple, but I can provide you that one. Yeah, also show you how to use the big integer class to do some simple operations, addition, multiplication. Basically, we do additions and multiplications. Okay, pretty straightforward. But you need to call the method. Okay, add, multiply. You need to call the methods. Yeah, you do not use the, operator addition. You do not use the plus and the multiplication. symbols. So you use the, method name, okay? Addition, you use add, call add. Multiplication, you call multiply. And so on, okay? Yeah. I will talk about that later, yeah. I will talk about using big integer class later. Yeah. Yeah. Pretty simple. Yeah. Okay. Yeah. All right. Yeah. So this is the first round description. Yeah. So I will post a detailed description document. Yeah. So in that one, I will provide a lot of technical, how to select input data, how to generate input data, okay? And how to, choose appropriate data size and so on, okay? Here, I do not give you that details. Yeah. In my description, I will provide you more details. Yeah. All right. Then